Optionals. They're specialty, kind of a specialty thing added to Swift, something that programmers have had problems with for years. That is defining a variable and forgetting to put crap into the variable. Therefore, Swift has something called optionals, where when you define a variable, you define it with the idea that it optionally will have a value. Therefore, before you use it, you must unwrap it. That is, wrap it inside of a if statement to make sure there's a value in there before you're actually allowed to use it. Make sense? All right. How many of you got it? 1 1/3 people?
75% of it. I got all of it. I even wrote the code.
Just garbage.
Almost done too. I have no life left.
I'm probably going to give these often, so you probably should pay attention and study previous class notes.
That'd be a good idea.
It's FYI.
I'm single now. My girlfriend's Swift.
Your girlfriend is Swift now? Okay.
Yeah.
All right. So what I want to do here is I'm going to actually, we're going to start messing around today with something called the Swift playground in Xcode. Okay, so I'm going to pop open Xcode, and there's already a homework assignment up that is due. I originally had it due Monday, but I guess it's due Wednesday because we don't have class on.
It takes like 2 minutes.
Well, that's fine. So I'm just being nice. So in any case, you have plenty of time between now and then to either sort out a Macintosh on your own or get down to the lab down there and mess with it there. But when you first come into Xcode, okay, which is our integrated development environment we're going to be using in here for writing all of our software, we have this tool in here called Playgrounds. So we're going to, we can say get started with a playground if you want. Otherwise, you can go to File, New, Playground. All right, and we'll just call this My Playground. That's fine. And which platform, iOS or OS X? For us, it won't necessarily matter, but choose iOS. That'll be the one that will give us some of the stuff that's the most similar to what we're going to be dealing with for Apple Watch. Apple Watch is, let's say, technically running iOS. It's actually kind of a bastardized version of it, but whatever. All right, so we'll start this, and I'll just throw this on the desktop for right now. All right, and what playgrounds do is they allow us to write code interactively. Okay, allow us to write code interactively. And we're going to use the playground today, and then you'll actually use it on your homework assignment to kind of explore these languages. And as I've mentioned in many of my classes, the things that we need to learn first in any new programming language is going to be how to define variables, how to ask questions, and how to do repetition, right? Okay, so we're going to learn all those things today. So we're going to start off by talking about variables. We'll come back here to overriding optionals rather. So variables, we have two kinds of variables. We have lets and we have vars. All right, a let variable type is a constant. Use this when we are creating a variable that we will not be changing. Special note, lets do not require us to give an initial value. But once a value is given, it cannot or can't be changed. All right, we'll see this as an example here in a minute. Vars, these are our normal variables. Use this when we are going to change the value of the variable. Okay, so most of the time we're going to use vars. Sometimes we might use lets. You might even say that it's never wrong to use vars all the time. Because what's the difference between a var and a let? Can't be changed. So couldn't we just create a var and just choose not to change it? Okay. Again, this kind of comes back to a self-policing type thing, though. If you use a let and you accidentally go and try to change that variable, it will scream at you. So for instance, if you're going to create a let, for instance, let's say something like this, let pi equal to 3.14, and then pi is equal to 5. It's giving us an error here saying cannot assign to let value pi. It's constant. Can't assign a new value to it. Right? So we'll get screamed at. But if I make pi of r, one moment.
Oh, it's because you have one as an int and one as a
No,
double.
I should be getting a different error message. That's fine. Yep. Remember last time I mentioned that sometimes with Xcode and Swift it does weird enter things and you sometimes have to reconvince it to make another pass? That was one of those examples. All right, so here's pi, holds the value 3.14, and then I put 5 in there a minute later. Print something to the screen. We're going to go ahead and print out pi. Notice the value of pi over there on the right. So println is equivalent to system.out.println in Java. It prints something to the screen, then presses enter. Print is equivalent to system.out.print in Java. Print something to the screen and does not press enter. Notice for pi, I put the number 5 in there, but when I printed it, it printed out 5.0. Why is that?
It was originally set as a double.
Hey, remember, Swift is a strongly typed language. Okay, even though we didn't define the type specifically that pi was built to hold, the second we put 3.14 in there, pi became a double. Okay, it became a variable capable of holding floating point numbers. Now, when I put 5 in there, no harm, no foul, but it's going to store it as 5.0. Make sense? All right, so I can no longer go back to pi being able to hold integers as integers. Go ahead.
What if you switch the two and did 5?
Oh, okay. Yep. So here we'll do 3 and 5.2. I'm going to have to do some convincing again. Okay, so now it's going to scream at me. Cannot assign a value of type double to a value of type int. So as soon as I gave it the 3, it became an int. Now I could say var pi like that, and then I can say pi is equal to 3. And now look where the error is. Type annotation missing. It's missing in patterns. So this is the language design side of things. We'll talk about this in the 470 class, those of you who are currently in there. If you define a variable, but don't start it off with a value, now you are required to give it a type. All right, so syntax for that is you put a colon and then the type of value you want to hold. So if I want to hold integers, I would say int.
Why is it giving the error there?
Well, same problem. Okay. Stupid. So they just press enter for it to kick back up. All right, so it's fine here, but now it's complaining that you can't put a double into something that's built for holding an int. Make sense? All right, so kind of simplified integers or simplified variables there. And we'll start off with just ints for right now to keep things simple. All right, so questions about variables, how to define them. All right. So now we know how to remember crap. Specifically, we know how to remember integers. Conditionals. Syntax for conditionals in Swift. If, Boolean expression, opening curly brace, body, closing curly brace. Notice that the parentheses around the Boolean expression, why won't you just stay as EXPR? Okay, notice the parentheses around a Boolean expression that we're used to from other languages like Java are not required in Swift. That doesn't mean that they won't work. I would still recommend always using the parentheses. I think it just helps with the structure. So for example, we can say if pi is less than 10, println woot. Notice no semicolons either. All right, so there's our woot. If I change pi to be 30, notice woot goes away. So playgrounds are a real-time type of simulation of our code. And I'll go ahead and take out the parentheses here. Notice it still works, but I really don't like the way that looks. It's not incorrect. Swift allows for it, but I would still encourage you to use the opening and closing parentheses around your Boolean expression. I think it's just cleaner. But in other languages like C, C++, and Java, the opening and closing curly braces were not required when you only had one statement following a conditional or a loop. Now, this is expecting the opening curly brace. So Swift has the curly braces as being a required portion of the language. All right, so whenever you do an if, it's no longer optional to have the opening and closing curly braces. For the few of you in here that are in the 250 class, you're going to see this next week when we introduce if statements in Java, and I'm going to say something along the lines of that the opening and closing curly braces are never, ever wrong. They're only required if you have more than one statement, but they're never wrong to use, so I encourage you to always use them, and it makes your program look more structured anyways. Okay? So, syntax for conditionals. If, let's say opening parenthesis, Boolean expression, closing parenthesis, opening curly brace, one or more statements, closing curly brace. So that's how we ask questions in Swift. Make sense? All right, now loops. We'll start off with our simple for loop. So we have for, opening parenthesis. Actually, let me just show you a syntax example of it.
Okay, before you push space after 4, just type FLI.
Oh, because it'll give you the whole, the fork. You like that? It'll also, if you do a little farther, I think it will give us, usually it gives you some command completion stuff. Because, for instance, one of the things I'm going to have us use for our assignment is arc4 random uniform to get us a random number, between, I think it's 1 and 100,000, something like that.
Mm-hmm.
All right, so we're going to look at a for loop here. So for, now in Java we would say int I equals 0, something like that. Well, that doesn't exist in Swift. We don't say int. So we'll say var I is equal to 0. We're going to keep going as long as I is less than 10. And then we'll add 1 to I each time. And let's just do a println I. All right, so that's going to show us our...
Semicolons
If you-
required there.
So why is
If
it...
you hit the little circle next to the I, it'll actually put it right under it. And then if you go over to where the 9 is.
I just had it all up, didn't I?
Yeah. You can do the same thing. Keep it there, though.
All right, where?
'Cause I got mine like this.
I see.
Yeah.
So if I do that,
Yep.
and then do that, and then do that.
Oh, no, you got to go over to where the 9 is on.
Oh, I have to do it on here.
There. Stand here.
All right, so you can see the output of your program. All right, similarly, if we want to look at a random number between 0 and 100, Here's 100 of those guys. It actually shows us a distribution, a quick look distribution when we have a bunch of numbers like that, or we can just look at the actual values. All right, so syntax for a for loop like that. Now, why didn't I make this a let?
Because you're changing it. You're incrementing it.
Right here, I'm changing it. I is changing each time through.
Yeah, you could have set woot as a let and then just print it out.
Yep. So I could have gone like this: let display be equal to woot, and then maybe do a println display. That's a reasonable use of a let, because we're never actually changing the value of display. Display is always woot from that point forward. It cannot be changed. This will show a bunch of woots. All right, so that's for loop. While loops, so we can do var, actually let's do, we'll do var I is equal to 0, while I is less than 10. Let's do some stuff. We'll do println I, then we'll say I plus plus. So it's saying that each of these lines happens 10 times in this loop, so that's giving us some feedback as to what's happening in the loop. This line actually displays stuff. This line does not. This line we have, it shows a linear progression, so I goes from 0 to 1 to 2. It'll show us those values, but it's not actually displaying things to the screen. These are the values that are being displayed to the screen. All right, so those are our while loops in Swift. We've dealt with integer variables. We can also store, we've also dealt with a string variable right here, storing a string. Chars, just like Java, we could say var C is equal to A for character A. Then we can say for var I is equal to C, keep going as long as I is less than or equal to Z I plus plus println I. What are you complaining about? Oh. Oh, it wants. I'm not doing a for each pattern. That's what I'm going to show you next. Does it not like me going through characters like this? Let me try this. Well, I had the separator here. Doesn't seem to want to spin through. That's its recommended fix. It doesn't want to go through letters of the alphabet with a loop. I think I can do for var I in a let me go to our class stuff here real quick. I have a reference to the different loopy types in here. All right, we're going to look at collection types here in a second. We'll look at arrays. But for right now, we have a for in loop. So yeah, it's 3 dots. Actually, it looked like with that, we didn't have to do a in a it doesn't like large swaths of that, it appears. I wonder if the for each doesn't like the bigger syntax. Does it specifically not like I is indexed like a special placeholder? Or does it not like going through characters? Yeah, it doesn't like going through characters. So this will print out that, but I want to loop through all the letters of the alphabet. I really can't do that. It's very weird. And there aren't tons of examples when you'd want to do that anyways, but you still should be able to do it. Whatever. All right, so that's a for in loop, so we can create a variable. In this case, they have something called index in a range of values, but this looks like it's numeric only. Right over a sequence, such as a range of numbers, items in an array, or characters in a string, but not letters of the alphabet. Fine. So let's look at arrays then while we're dealing with the for in real quick. So if we look at collection types, we have this idea of an array. So here would be an array of integers. So let's grab this. Come up here. I'm so happy it lets me delete all that. So I have some integers. So the syntax for this is var, name your variable, equals a value. The value for this guy is going to be an array of integers. Okay, so open square bracket, close square bracket with int in the middle, the type of value you want to store in there, and then open and closing parentheses. What it does is it creates this empty array. So arrays in Swift kind of act like linked lists for those of you who've had 300. All right, so we add stuff to, in most languages it acts like something called a vector. Relatively unimportant, but we're going to append things onto this list. So if I say for I in 0.100, and then I say sumInts dot append I, and notice that 100 is inclusive. So this is going to go from 0 all the way to 100. So if I were to look at sumInts after this, I think it has a facility, yeah. So 0 all the way to 100, including 100. Go ahead.
Can you define the values in variable or in the array and array definition as you can in Java?
Oh, like you want to do something like this. You want to have a second one, let's just say, var more ints, and this guy's going to equal 1, 2, 3, 4. Doesn't like it in that syntax, but can I do this and give it some initial values? Bet you that works. Okay. So you would use square bracket. Okay. So some array thingies. We append stuff to the array. We can get the count of an array. So I can come down here and I can say println sumints dot count, and this will give me 101, the number of elements that are in sumints. So that's how we get the length of an array. Okay, we use count. We also have some cool things to that we can use to do something so many times. So for instance, here is like a shortcut syntax for creating an array of doubles. So if we want to have an array of 100 things all initialized to 0, we can come up here and we can say I think it's in the constructor guy here. It's going to give me the fill-in. There we go. We just had to start typing it. So there's this is actually calling the constructor for the array builder. So how many of these guys do we want? We want 100, and we're going to fill it with -1s, let's say. So right off the bat, that's going to go ahead and give me 100 -1s in an array. So we have a default value. Another little shortcut that a lot of other languages kind of require a two-step process. Create array, then call usually like in Java, it's arrays.fill. You pass it the array and you pass it the value and it fills that array up with that value. Or you just write a quick little for loop and you're done with it. So, a lot of these are just shortcutty type things. I would say that I don't use most of these. I do our traditional for loops and stuff like that. But I can see how some of these might be useful. All right. Here is our array literals that you asked us to do. Create a quick array filled up with some stuff. So let's look at string concatenation. All right, so we'll say s, and then we'll say println s concatenated with world, and we get hello world. So we have the same means of doing concatenation as we had in Java, the plus sign. That's one way we can do it. Now, for those of you who've ever programmed in C++, sometimes it's beneficial for us to be able to drop words inside of our, drop values of variables inside of our strings. Oh, looks like sound like a motorcycle. Okay, drop values inside of our strings without having to break our string up with a whole bunch of plus signs and stuff like that. That can get kind of annoying. So if I want to print out hello world, I don't know, let's just throw s back on the end there just to make it more cryptic for us. All right, hello world, hello. All right, something like that. An alternative way we can write this is we can create a string. In the middle of the string, we'll put world, and then at the beginning, we would do s, s. All right, so these two lines are functionally equivalent. So backslash open close parenthesis is our placeholder syntax for inserting a variable inside of a string. So any variable I want to put inside of here, I can do. So if I have var a is equal to 7, and then I put a here, there's my 7 world hello. Make sense? So if you're kind of building custom string outputs or something like that, using this placeholder syntax is more often than not going to be more convenient than concatenating a whole bunch of stuff together with plus signs. Just a thing. So from a Java developer's perspective, Java is nice that you can just sit there and manipulate strings really quickly with plus signs, but if you came from the C or C++ world where you could put placeholders in there, the second you were trying to concatenate on too many variables in the middle of strings, you started getting kind of upset. So this is a nice little shortcut for that type of thing.
If you do like a list, does it keep the syntax of doing a list, so you'd have the opening bracket and closing bracket with the commas separating all this stuff?
You mean if you print it? If you print the
so
list?
If you were to like sub out, like it make the
Go ahead and create another variable with an array in it?
Yeah.
Something like that? Okay, so we'll create sum ints is equal to 1, 2, 3, 4, let's say. And then you want to put sum ints in here. Yeah. Because the sum ints is that array has a toString method that gets called automatically. And understand these are things that are going to be relatively uncommon to do in practice, except when you're just printing out the contents of your array to make sure it's filled with the crap you want. Usually, especially when we start getting into writing our apps for iOS, we're going to use arrays to hold collections of numbers, but then what are we going to do with those numbers? We're going to display them in like a list view on their screen that you scroll through with your finger, right? You're not going to show it in like, console text like this. We're just kind of learning the basics of the language. All right. So let's see, any other collection types in here? So iterating over an array. So arrays are what are known as iterable. So I can come in here and I can say for val in sum ints, println val. And this will show me the contents of sum ints. 1, 2, 3, 4. Okay, but I went through it the first time through val is the first element in sum ints, so it'll be the 1. Next time through the loop, it'll be the 2. Next time through the loop, it'll be the 3. Next time through the loop, it'll be the 4. And then we ran out of stuff inside of sum ints. Make sense? Don't worry about sets right now. We're going to actually deal with those when we get into our list views. This is like the math set operation stuff, unions and that kind of stuff. Dictionaries are actually fairly helpful. Do I want to show you them now? Dictionaries are a bunch of key value pairs, like so you can have, color equals red, name equals Mike, all in kind of an array type thing. So we no longer, in older languages like Perl, for example, before they were called dictionaries, they used to be called enumerated types, where we can give, instead of bucket 0 or bucket 2, we can go to bucket color and get the value red. Go to bucket name and get the value Mike, that kind of stuff. Okay, so let's forget about dictionaries for right now. So I only want to introduce so many things to you. Okay, so basics. We talked about lets and vars. We talked about how to create a variable and give it an initial type before you give it, and then you can give it a value. And at that point in time, it's set, especially if it was a let. We can define multiple variables at once, but you can do that in other languages as well. I just typically don't teach that. So if you want to define red, green, and blue to all be doubles, you can define red, comma, green, comma, blue, and say these guys are all of type double. Okay, here's our constants. So this is kind of the stupid thing you can do in Swift that I don't think makes any sense. You can use emojis. Okay, so you can actually have variable names that are emojis.
Oh dear God!
This is a dog cow.
Cat does the dog.
Code exclusively emojis.
Code exclusive emojis. So it is allowed. It exists in the language. I have never seen a situation where that would be beneficial.
Oh yeah.
Just saying. Just saying. And part of that is this idea that there's a programming mentality. Okay, and let me know if this is different for you guys, because I am interested in this, because to me this seems like a completely useless feature. Okay, but emojis are a very popular thing that people use now for like texting and things like that. Well, I've only recently gotten into it because my Apple Watch lets me do smiley faces. And before that, if I wanted to do smiley face, you do what, the colon parenthesis, right? That's a smiley face. That's not. I mean, those aren't emojis though. Emojis let you do all this sorts of other stuff. But you know, the punchline is, do let me know as you get into this if you actually find it beneficial.
It's just taking dumb typing to the extreme.
Well, that's what I'm saying, is let me know if you actually find it beneficial to go and find the emoji that you find that you want to represent this variable, because it's better to visually represent it than be able to just type a variable name real quick.
I mean, it's only one. I feel like we move on instead of.
Yeah, but you got to go and search the emoji.
Yeah, if I was on my phone and I was programming for some reason on my phone, it might be.
Yeah, you got to pop up your emoji keyboard.
Yeah.
But that's one
Like-
click. So it's 2 clicks instead of 3 to type dog.
So if I use TeamViewer and then go into my laptop, I can have all the emojis I want from that keyboard.
So, let me know. I probably will not use it as examples in here, but
What
whatever.
if I just think my code's really crappy and want to put a pile of poop on it?
I'm very confident I will be able to read your emoji-based variables. So do what you like. I'm telling you that it exists.
Everyone from now on only uses emoji variables.
I've been reading code for a very long time. I'm not concerned about that, but I won't be using emoji-based examples in class until somebody convinces me that it's a good idea. Or I get a really awesome set of emojis. And then things could change. All right, so we talked about vars versus lets, and kind of what that means. We talked about printing stuff today, so that's all that. Comments, same kind of comments as we have in Java. Single line comment, 2 front slashes. And by the way, there's a link to this whole thing on Blackboard over on the left, so I just clicked right out of the class. Multi-line comments, slash asterisk with an asterisk slash at the end. Semicolons they're not required in Swift. If you want to have more than one thing on the same line, you have to divide it by a semicolon, and this is something we're going to talk about in the 470 class. The parser that is going through your language, is going through your Swift code here, it has to be able to differentiate statements from each other. So if you put them on the same line, Swift is not going to be able to tell the difference between this statement and this statement. Okay? But if we put them on separate lines, the carriage return can act as the separator. Make sense? Okay, so if you happen to just be addicted to putting stuff on the same line, use the semicolon, otherwise just do it the Swift way. Make sense? We talked about integers. Here they're showing the 8-bit integer minimum and maximum value. This is equivalent to what we talk about in Java with the byte data type. Okay, this just looks scarier when you have something called uint8. What does uint8 likely stand for? I'm telling you this is equivalent to the Java byte, but what do you think uint8 means? It's actually not quite equivalent to a byte. Almost equivalent to the byte. Notice see the minimum and the maximum value here? What do you think the U stands for? Unsigned. Yep. So U is unsigned 8-bit integer, which is going to be 0 to 2 to the 8th power, which is 255. Okay? So they're just kind of showing that you can get the max and min value of the type. So our type is U int 8. Min and max, I assume there's a int 8. So if I do print int dot min, that should give us negative 2 billion-ish. Oh, no, mins are actually, what's the, integers are what base, or how many bits in this language? Just by looking at this. It's not 32, what's the next logical? It's 64-bit. Okay, which means that, I assume longs exist here. Oh, they don't. So in this language, an int is the old school long. So do we have or do we just have int 16s? So an int 16 would be equivalent to a short, and int 32 would be equivalent to an int in Java, that's your negative 2 billion, and int 8 would be equivalent to a byte, negative 128. I wonder if you could just put anything there? No. Is there an int 64? There is.
Big number.
Good.
No. So int 64 and int are equivalents. All right, but relatively unimportant for us, more trivia stuff. But when I teach the Java class, what do we talk about? We talk about the default being int. And if ints aren't big enough, we go to longs. Because ints are 32 bits in Java, longs are 64 bits in Java. Well, the default in Swift is int, but ints are 64. So int is to Swift as long is to Java. Make sense? But we don't care about memory anyway, so it's fine.
So will int by default store decimals?
No,
By that lot? Okay.
no, it's a whole number. Yeah, it's a whole number that just can be represented as 64 bits. So it's, what is this? I think it's negative 9 quintillion to positive 9 quintillion.
Okay.
Double, here's our doubles, has a min and max. Oh, double doesn't have a min? That seems dumb. I don't get a min from that? Oh, whatever. All right, so that's that stuff. Here's int. Oh, it tells us int changes whether you're on a 32 or a 64-bit platform, but I don't know actually if Swift can run on a 32-bit platform because Apple doesn't make any 32-bit platforms now that support Xcode. So I guess it would have to be this is kind of like Microsoft and their .NET component architecture where it's like, well, if it ever did run on a 32-bit platform. So if your C# code ever found its way onto a Mac, it would run fine as long as the .NET component architecture was there, which it's not. Okay, so there's our unsigned ints. Floating point numbers. Doubles are 64-bit. Floats are 32. Same thing as we advertise in Java. Numeric literals. You can represent things in different bases. Octal integer. You do. So it's what? This is the numeric base. So this is 0B for binary, 0O for octal, 0X for hex. Okay. Oh, no, this is giving us the representation. We'll have to look at that. Not something we're going to use anytime soon. Integer conversion is something we might use, and I know we're out of time. Let me just point something out here real quick. If we ever needed to convert an int from a string, well, here, let me just show it to you real quick. If I want to do this, you just say, I think it's int 125 plus 1, I think should give us 126. Isn't that the how you convert it? Or is it just 2int? I think it might be 2int. Doesn't really matter. I'll show you next time what the conversion is. You have everything you need to do your homework assignment. So your homework for Wednesday is going to be to go into a playground, display hello world, do some loopy stuff, basically things that we drilled today. Okay? Proving that you have access to Xcode and can use some stuff.
Fierce.
All right, I'll see everybody on Wednesday.
My variables will all be